what you pick out are the young stars that are very massive and hot. And so you can see that these young stars are in the spiral arms. And if you look at it in the infrared, what infrared tends to pick out is the dust. And so this is actually false color infrared, even though, you know, it's blue. But this, and so you see these dusty features, and some of them are ring-like, which has suggested that M31 had ate somebody recently, a while back, and that we're seeing the remnants of a galaxy come into Andromeda, it perturbing it, which created this ring-like structure that's visible in the dust. So you look at it in different wavelengths and you see different things. This is kind of an iconic photo. This is M100. This photo, it's maybe not the most beautiful spiral. It's a spiral galaxy. This was the image. I believe this is one of the first images that was released when Hubble's vision got fixed. Not Edwin Hubble, but the telescope. And so this is M100. It's a beautiful spiral galaxy. So I thought I would show you our galaxy. Many of the galaxies are spiral galaxies, and the spiral galaxy, when you look at them edge on, this one we're seeing it face on because they're kind of prettier to look at face on. And when you look at Andromeda, it's tilted at about 60 degrees. But edge on, we can see our own galaxy because we're not at the center. And it's like being out on Lake Michigan, and you can see the panorama of the skyline. But you can't do it with visible light because of all the dust in the disk. And so this is an infrared image, and the infrared light penetrates the dust, and you can see how thin the disk is. You can see the bulge of the Milky Way, and then you can see other stars in what's called the halo of the Milky Way. This is an interesting image of the Milky Way. This one's pretty nice to look at, isn't it? Mm-hmm. So this is an image taken by a European telescope, so we won't tell you what the name of it is. And this is the center of our galaxy. So it's a region near Sagittarius A. So these are all stars, and the two arrows were discovered on this image of the sky, suggesting that there was something interesting. At least that's what I heard. And this is a very high-resolution photograph. The distance to the center of our galaxy is about 25,000 light years, and this is 1 light year across. So this is a very small region. And what's interesting about that region is there's a big black hole there. And one of the discoverers of that black hole is Andrea Ghez, who grew up in Chicago, and her mother led the Renaissance Society for years. And I want to show you the way that Andrea and others discovered that big black hole. They looked at the stars there and mapped their orbits. And so S1, S2, these are just names of stars really close to the center of the galaxy, and they mapped out their orbits, literally taking images at different times, seeing how long it took to go around the center, and they were able to determine the mass of that black hole to be about 3 million times the mass of the sun, and demonstrate that there was a black hole there. So this is another image, but on a much larger scale, of looking towards the center of our galaxy, made by the Chandra X-ray Observatory. So now you're looking at the really energetic things in the galaxy, things that are giving off X-rays, neutron stars and black holes, and you can see the center of the galaxy. And Chandra zoomed in on the center of the galaxy. So now the resolution isn't so good because you're looking at a very small field. And this is where the black hole is. And by studying this, you can see as black holes go, fairly faint emission of the material that's falling in the black hole. So the black hole at the center of our galaxy is not very active. It's not eating up very much. And you see black holes when material falls into them, and not very much material is falling into that black hole. So here is a barred spiral galaxy. So you can see the bar, and you can see the spiral arms again. Very pretty to look at. This one's interesting. If I could see my notes here, and I can't see my notes. Remember what you don't know the number. I'll just make up the number. NGC 1746. One of our colleagues is leading a project in Chile where they built a really big camera, 500 megapixels, to study dark energy, which we'll get to in a few minutes. And this was the so-called first light image. And on first light, you want to take a picture of something really pretty. How many people like the sombrero? So this is the Sombrero Galaxy, M104. So Messier, it's one of the last objects that Messier found. And Sombrero Galaxy, what you can see here is its disk. So we're almost seeing it edge on. And this darkness here is because of the dust. And what's interesting about the Sombrero Galaxy is this thing. You might say, well, what is that? Well, you remember the image of our bulge earlier? Sombrero has a big bulge. Apparently, when it was a young child, it ate too much, and I don't know why. It has a very big, the part of the galaxy called the bulge is very big. So in our galaxy, the bulge was just really small. And so what makes the Sombrero interesting is the big bulge. And here again, what you learn from multiple images of it. So if you look at it in the optical, unfortunately here displayed as green, you see the dark lines, which is where the dust is. You see the bulge. If you look at it in X-ray, you see these individual X-ray sources. So things like binary stars and neutron stars that really jump right out at you. And then if you look at it in the infrared, you see the dust. And if you put those all together, you get this composite picture, which doesn't look quite real. Is this a pretty picture? Okay. Oh, now we're getting to the fun part. So 100 billion galaxies. That's a big number, but the universe is big. So, do they ever bump into one another? And it turns out, so this is a wonderful scientific question. So if you had asked an astronomer that 30 years ago, a typical astronomer would have said, no, galaxies don't collide. The universe is really big. And we now know that every galaxy has suffered a fairly major collision. So galaxies collide all the time. It just was that our instruments weren't good enough to see this. And so this is called the Tadpole Galaxy. And this is a wonderful image. When they did an upgrade of the Hubble's instruments, I think John Grunstelt, the University of Chicago graduate, led that upgrade. And they replaced the instruments. They did another deep field called the Ultra Deep Field. And you can actually see this is part of the Ultra Deep Field. So you can see some of the things that you saw in the Hubble Deep Field. And these are, this is a collision of galaxies. So what happens when galaxies collide? So one of the things that happens is the stars pass through one another, but the gravity field of one galaxy rips apart the gravity field of the other and pulls out things like a tail and pulls out things like that. So the collision changes the shapes of the galaxies. This is an absolutely spectacular collision. You may have seen this. Some in the audience may have seen this. This collision happened about 100 million years ago. I'm just kidding. This is called the cartwheel. And what happened so this is actually a galaxy. And I believe it's this galaxy passed through it about 100 million years ago. And when it did, it shook things. And it shook things and sent out a shock wave that compressed gas. And the compressed gas caused stars to form. And so this ring is a remnant of that collision. And you can see some other galaxies here. And again, here's the montage in different wavelengths. So the cartwheel is evidence of a galaxy collision. And here's a montage, a Hubble montage of galaxies colliding in various ways. So this looks like a galaxy that came through that galaxy. Here's two galaxies about to collide. It looks like these have already, I think this may be the antennae. And you can see that these are called tidal tails that get pulled out. Here, these two galaxies are dancing. It must have been from some presidential inauguration. So just absolutely, these are in the midst of doing something maybe we shouldn't be watching. And so colliding galaxies, it happens all the time. This is a wonderful image. It's complicated, so I'm going to have to walk you through it. There's a wonderful story here. It might even be true. So this is called Centaurus A, and this is dust in Centaurus A. Ignore these things for the moment. They somehow don't look like they belong in the image. And, they've been montaged in, and I'll explain them in a second. Centaurus A is a galaxy that's got a big black hole, much bigger than our black hole. So our black hole is about 3 million times the mass of the sun. This one's closer to 1 billion. So we kind of have a puny black hole at the center of our galaxy. And this galaxy is seen eating another galaxy. So another galaxy collided with it, and it's digesting that other galaxy. So what are these things? So these things are jets of energetic particles that are streaming out of the accretion disk of the black hole at the center of Centaurus A. And these jets are imaged in the radio. And so what's at the center here is a Hubble image that's pretty much, close to true color. This is false color. This is a radio image of the particles in these jets. And one of the stunning things about this image is that the jets are pretty straight, which means that this black hole, which is spinning, hasn't wobbled very much. What do we got? Oh, this is another fun one. So this is a montage. This ignore this central part for a second. These are two galaxies that are colliding. We're pretty certain that most every galaxy has a big black hole at the center. Millions, billions, many close to billions times the mass of the sun. And again, I told you galaxies collide. Oh, well, if galaxies have black holes at their center, the black holes must collide. So how do you image a black hole? Well, a black hole, if material is falling into it, shines in the X-rays. So you use the Chandra X-ray Observatory, and you see, can you see two little bright spots there? Those are the two black holes that are about to collide. So these two galaxies, their black holes are about to coalesce. And about means in a few 100 million years. Okay. This is a cluster of galaxies. And the colors are pretty much true, although I told you don't worry about true colors. And if you look at this, is anyone getting dizzy? So do you see these arcs? You know that damn Hubble telescope, $2 billion, and you would think it would take good pictures. So these arcs are not a defect in your Hubble telescope. These arcs are actually real features. And the story here is, again, interesting. I'm going to get sidelined here just for a second. So these arcs are very prominent in all the, we call them deep images, where you use a big telescope exposed for a long time. You will see these arcs. And these arcs were only discovered in the mid-1980s, even though they'd been there in images. But people just, I don't know what that is. And once you know what to look for, you see them. How did these arcs come about? These arcs come about because the gravity, well, let me orient you here. So the cluster galaxies are all kind of yellowish or orange, whatever color you see. These fuzzballs are the cluster galaxies. And do you see these whitish things or bluish things? So those are galaxies that are way far away, and their light had to pass through this cluster. And according to Einstein, gravity can bend light. And what does a lens do? The lens bends light. And so gravity can act like a lens. And so this is called a gravitational lens. And when it does, actually I don't have one that's produced multiple images, but what it does is it stretches, it shears the shapes of galaxies. So let's look at this. This is not a funny looking galaxy. This is a galaxy whose light has been distorted by the gravitational lensing and is sheared. And so the shearing goes along a circle. So you can see all of these things are sheared. And we're going to come back to this in a while. So this cluster of galaxy has acted like a lens and distorted the light of the more distant galaxy. That's a test slide. So actually, I thought some slides are boring. So this is, in fact, this cluster's telephone number is Abell 1689. And this is what Abell 1689 looks like in the X-ray. So, this is lots of X-rays, and this is few X-rays. So it's not very interesting in the X-rays. Although the X-rays are quite interesting in the sense that most of the material in this cluster of galaxies, most of the atoms in this cluster of galaxies are not in the galaxies and the stars themselves, but in the hot gas in between the galaxies. And that hot gas is so hot that it gives off X-rays, and there you've seen it. And in fact, what's interesting about this is when you calculate, well, how much hot gas